take them downing, take them downing, take them down. As you look, the whole room explodes. Take them downing, take them downing, take them. As you look, the whole room explodes.
Cool. Hello, hi, thanks everyone. My name's Johnny Miller. I'm a solutions architect at a company called DataStax, and we basically build Apache Cassandra. We contribute around 80–90% of the code into the Apache project, and we're very keen on Cassandra and supporting the community around it. And we also have a kind of a commercial offering around Cassandra as well. But and we are definitely looking for people. So if anybody's looking for a job, please have a look at our site, where it's hard to find good people. And every time I come out to Israel, I'm always really impressed with the Cassandra community out here. There's some very, very early adopters of Cassandra. So, I mean, it's been a really interesting time over the past couple of years. I started using Cassandra. I used to work for a company called BSkyB with 0.6, and it was pretty early on. And it's been just an amazing growth over the past couple of years. Can I ask who actually knows what Apache Cassandra is? Have they used it before? Fantastic. So I won't go on about it too much. So I mean, really, if you don't know what Cassandra is, it's a very, very scalable, distributed open source database. It's really a hybrid of Dynamo and Bigtable. We take a lot of the distribution algorithms from Dynamo, and we use the Bigtable storage model under the hood. But really, the kind of key point to get in your head, it is a completely masterless database. There's no single points of failure. There's no master slave. There's no primary, secondary. All nodes are equal in the cluster. And this gives us a lot of benefits, because it means it's much easier to scale, failover, and we can do things like we can have genuine 100% uptime, whether you're adding nodes, replacing nodes, upgrading the software. There's no reason for downtime, and that's an appealing thing. And it's fundamentally, it's been built from the ground up to be data center and rack aware. So when you're going into a multi-data center setup, it's very, very simple to get running. And because we've got rack awareness in there, we can mitigate single points of failure in your actual hardware as well, by ensuring your data isn't replicated always onto the same racks. So these are usually a lot of the reasons people use it. Certainly our poster child for Cassandra's Netflix. Netflix are using DataStax Cassandra across their entire estate. They have in excess of 2,500 Cassandra nodes, 80 clusters. They're across 4 regions, and they're taking in excess of 1 trillion transactions a day through Cassandra, and that's a lot of transactions. That's a lot of traffic, and and to give you context, this is not despite 2,500 servers, they've got 4 or 5 guys looking after this. This is not a difficult deployment to work on. So what we offer is open source tooling, drivers, the documentation, the development, and when you want support or you want to use extra features, security, analytics, search, stuff like that, there's other things you can use. So what do I mean by the topic of this talk is going native with Apache Cassandra. Now, historically, the way you would have developed an application against Cassandra was using Thrift, and you could use Hector, you could use Netflix's Astynax, and this was how the early versions of Cassandra were designed to work. And what we've done with Cassandra 1.2, we introduced Cql 3 and the new native protocol for your client applications to communicate into Cassandra. And there was genuine reasons why we did this. I mean, I can say from a personal point of view, I don't think Thrift is a good protocol for databases, but it also gave us issues with how, there's a variety of there's Hector, there's Astynax, and how do you manage the kind of evolution of the database when you're trying to keep up to date with Thrift and what's happening in the database. So we took the decision, look, we need to have a better way to use it, both from just a general protocol performance, but also from an ease of use and productivity side, because Thrift is hard to get your head around. It's not that natural to you if you've come from a relational database. So what we did, we introduced CQL and the native protocol and the native drivers. And I'm going to call this out just in case. I would expect there's probably a lot of Thrift guys here. There is a proposal now in the community to freeze development on the Thrift side of Cassandra post 2.1. So it's just a proposal. It's not anything that's set in stone, but it's something to be aware of, that there's definitely a movement away from Thrift towards the native CQL approach, and it's definitely something to consider. And I'd certainly recommend, if you're starting from scratch, you're building a new app or a greenfield project, you should look closely at the native CQL side, because there's going to, right now they're pretty much on par with, well, actually the CQL is a bit richer, but you're going to start to get less and less, more and more differences between what you can do with both. So, there's a great quote from Jonathan Ellis, the Apache chair, saying, it's old. CQL3 it's a mature language. It's better API. It's easier to use. It's very performant. It's got a lot of rich features, and it's definitely a lot easier to learn. When I started on Cassandra with Thrift, I was tearing my hair out. I found it really hard. So, CQL. So stands for Cassandra Query Language, and it really is. If you know SQL, you're going to know CQL. Yeah, it's very, very similar. It's intentionally done like this, so you're not going to spend time learning new things. You should be as productive as you are moving from SQL over to CQL. And you've got all the usual statements you have in there. You've got your creating your tables, selecting from tables, inserting, updating, creating secondary indexes, users, permissions, all the stuff you'd expect from a database. But it's also important to understand that with CQL, it's not SQL. Cassandra is not a relational database. You still need to be conscious that you are running it under a distributed database. There are limitations to what you can do if you compare it to a relational database, because it's distributed, because it's masterless, because there's no locking in there. But it should be, that should look very familiar to you all. So you can now connect up, start modeling your data with the tooling you're familiar with. There's a couple of extra things in there. Just want to call out. We have support for collection data types. So you can create a table and you can have sets, lists, and maps in there. But if you're going to start using collections, there are some performance considerations to have around that. And definitely favor sets over lists, unless you have a genuine reason to have duplicate values in there. And Cassandra 2.1, which is in release candidate right now, and it's due to go out towards the end of June. You're going to also have the ability to apply indexes onto your collection. So you'll be able to execute select queries that can drill down right into the payloads of your collections. And that's pretty cool. That's a very powerful thing to have. And I always put this slide in here whenever I'm talking about development in Cassandra, is query tracing. Query tracing is always going to be your friend when you're starting to code and model and develop against Cassandra, because it's just like doing a query plan on any database, but it will tell you exactly what's happened as part of the execution of that query, which nodes I've gone out to, how long it's taken for each of these nodes to parse the statement, come back, etc. So when you're looking at diagnosing why my query might be slow or it's not doing what I think it's doing, this is going to be your friend. And it's also pretty educational. You will learn by understanding if I try this or if I do this, what's the effect on the underlying query. I definitely suggest using it, but only use it for development and testing. This is not something you want to have in production because it's obviously extra overhead on your database, but also the query trace is actually persisted into the system key spaces as well. So it's not something to run on every single query, it's for you to help you to diagnose. And we also introduced, I could probably stand here for 4 or 5 hours talking about CQL. There's a ton of features in there that you'll be able to use. We have lightweight transactions. This gives you the ability to perform essentially a compare and set operation on inserts. So you can say, insert this if this applies. You've got batch statements, which is, as you guess the name, this is a ability to apply multiple mutations to your data, and it's atomic as well. So if you have a lot of inserts, you'll apply the batch, and it's an all or nothing operation. You can also embed lightweight transactions within batch statements, so you can do very, very fancy approaches. It's quite powerful. And we have time to live on your data, so you can insert a record, and you can apply a time to live on that record or on the cell. And this is quite handy for self-pruning your data. So if you're running in a kind of a time series type of data model, this is great because you can write all this data into there, and it will continuously prune itself off at the end. And that's pretty nice. We see that a lot. Plus, absolute tons more to play around with, and I'd suggest having a look at it. It's fairly rich. So, this microphone's really in my face. So the Cql Native Protocol. So this was the other part of what we changed with how your client is going to communicate into Cassandra. If you look at the way Thrift would have worked, it's basically an RPC type call. Your client makes a request, gets a reply, request, reply. And the way it works with the native protocol is the driver has a bunch of sockets open permanently, and we're basically request pipelining over these connections. So you're essentially, by default, you're firing approximately about 128 concurrent requests over a single connection into Cassandra. And the reason that's cool is if you look at how distributed systems need to scale, this is a much more friendlier way to do this. So when you're in situations where you start to hit problems with, can I actually open as many sockets as I need? This will help you a lot. It's pretty nice. But also, what it gives us is the power to push notifications to the client driver as well. So there's a two-way communication going on there between your client and Cassandra. So as you change your Cassandra topology, so you add nodes, you remove nodes, you introduce new data centers, you change stuff. These technical events are pushed to your client driver. So that means the client driver is always up to date with how things are happening, latency, everything. And because it has this information, it can make very, very informed decisions as to what it should be doing. And I'll show you some of the ways it will do that. The client driver is also completely asynchronous, where it's certainly on the Java side, it's been built using Netty, and it's designed for very, very high frequency, multi-threaded queries and requests into Cassandra. It's very, very performant, and yeah, you can. When I go into the native driver, you'll start to see now some of the more interesting things this gives you as a consequence. So, in terms of native drivers out there, we have quite a selection to choose from. By all means, DataStax, we make some drivers. There's also a bunch of community drivers out there as well. But yeah, I mean, if you're Java, Python, C#, etc., these are all there for you to use. But yeah, and we make a big effort to try and make sure that all languages are equal. We don't have a different way for if you're Java or you're not Java, you need to use a different way. We try to make it the same experience for all the languages we've got. So what I'll do is I'll take you through some examples now of using Java, because I'm a Java developer, how you might want to connect up and do stuff. So this slide here, what you're looking at there is how your client driver would instantiate a cluster. And this is saying, and it's also important to remember that this cluster object should be a long-lived object. This is not something you will be creating and throwing away regularly. So we use the builder pattern for a lot of this stuff, so you can, if you like that type of way of developing, it's going to be very familiar to you. The first thing you see there is adding contact points. Now, it's important to know that these aren't single points of failure. People think, well, if those two contact points subsequently go down, is my client going to stop connecting? That is not the case. This is really just how when this cluster object gets instantiated, it needs to go, hey Cassandra, what are you? Where are you? Well, tell me everything about you. And these contact points, that's all that is. If you know Cassandra, it's just like seeds. It's just how it discovers what's going on around there. And off that cluster object, you'll get yourself a session object. And again, this is a long-lived object. You do not want to be creating these all the time. And then you choose, okay, on my cluster, I'm going to connect. You can explicitly specify your key space or schema to connect to, or you can just connect straight through, and then you need to qualify the key, as you would expect, you'd qualify that key space in your CQL. And then there's a very simple execute method there, which you call, and that will give you back some data into which to do stuff. So that's a fairly simple example there. So here if I show you reading from a table. So again, I get my session, I execute this, and I get back a result set. And then from this result set, I get back a collection of rows, which I can then iterate through and do what I want with that data. Now, this should all be very familiar with you. If you've used Java, you've used JDBC, this is nothing, you should be all comfortable with this. This is very familiar. But where it gets which is where I quite like it, is where you start to get asynchronous on your reads and your writes. And the example here is I'm doing a select and I'm calling an execute async. And what this gives me back is a future, which I can then do some very, very cool stuff. And it's important to know that certainly in the Java side, it implements Guava's listenable future interface stuff. So all of the very cool things you can do with Guava about registering callbacks, etc., you can now do with your driver. So I'll show you a little example here. This is a read with callbacks. So all I've done here is I've called this execute async, and then I add a listener for this, which then goes off and does something with that. And this is very, very handy to do, because one of the nice things you should always think of with Cassandra is breaking things down into small queries and firing them as quickly as you can into Cassandra. You want to soak Cassandra as much as possible. I often find people, they start to get blocked on the client side. They're not pushing Cassandra hard enough. And this gives you the ability to just chuck as much requests into Cassandra as Cassandra can take, register a listener. When it comes back, you do the next step in your processing. You will see performance benefits from this. And it also means you can start thinking about parallelizing your calls into Cassandra. So this very, very simple example, I'm going to say, okay, I want to just fire an absolute ton of selects or an absolute ton of inserts into Cassandra, just chuck them in there. I'm done. I then get my futures back, and then I iterate through those and do what I want with the response on there. And that's a really nice approach to how you should look to design your code. And this is a good tip to have. Using the async and future stuff really does give you a lot of benefits. I mean, the problem with doing a very big query, for example, say it's a huge select, and if you hit that on that one node, Cassandra has got latency awareness in how it chooses to route your requests, and it will sometimes skew that latency, not out of something's wrong, but just it's doing a lot of work. So breaking things down into smaller bite-sized chunks means you get a much better awareness of latency across the cluster. And the other one that's quite nice if you break things down into small queries is retrying when things go wrong. You don't have to do the whole thing again. So this should be your friend. And there's obviously, these are Java examples. There's obviously differences between the languages, but this is pretty much the same across certainly Python, the C# stuff, etc. This is the approach you should look to take. Other thing you've got, and this should definitely be familiar to the Java guys in the room, if you've got prepared statements as well. And these are just like prepared statements in JDBC land. These are prepared, compiled, and reused, so you get that efficiency benefit from it. You bind variables to this, etc., and you call it and you execute stuff. So it's a very nice feature to have. And you also have the ability to programmatically build up your queries as well. So if you don't like writing CQL, if you want to, and I see people using this for, conditional queries. So you have a complex algorithm and you want to programmatically build the queries as opposed to, generating weird strings and stuff. This is a nice approach, and a lot of people are like this way of building stuff. So this example here is simply a select from a specific table where username is equal to Johnny, and you've got the ability to do this. Important thing to look at there as well is, as you may or may not know, Cassandra is a tunable consistency database. What you do with Cassandra is per request, per read, per write, you define the level of consistency you want with your request. Can I ask how many people know cap theorem or consistency? What I mean by that? Okay, that's a fair few. But imagine it like what you're saying here is you're saying, how long do I want to wait as a client for an ACK back from Cassandra? So if you imagine you've created your key space or schema in Cassandra, and you've said this schema is going to have a replication factor of 3, i.e. there's going to be 3 copies of my data in my cluster. And when I say consistency level of 1, as soon as one of those acts back, as from a client point of view, I'm happy to move on. And you can go stronger than that. You can go up to 1, 2, local quorum, all quorum, etc. But always remember, the stronger you go with consistency, the less tolerant you are going to be to failure. And that's your trade-off to always be considering. But what you default is consistency level of 1, but you can also explicitly specify them just like that on all those, similarly on all the other queries we have there. So you then get into ways of, well, how do I actually tune my client in an efficient way to, connect in, how am I connecting in? It used to be by default, it was essentially just round robining between the nodes, but now the default is DC aware. But what you can do is you have this concept of attaching a load balancing policy to your cluster. The example here is a data center aware load balancing policy. And what you're doing here is you're telling your client, I have n number of data centers in my cluster, but the one I want you to connect to first, your preferred data center, in this case is DC1. And it's not that if DC1 is not available, if you want it to, your client will connect over to one of the other data centers. It's just a way of saying, I would prefer you to use this data center. The other thing you've got is you've got token-aware load balancing policy. And this is quite nice. What you're doing with specifying a token-aware load balancing policy is you're saying when the client chooses one of these nodes to connect to, try and choose one onto which the data I'm writing or reading I know resides. Because this is the nice thing. The client's being informed of the partitioning of your data all the time as it changes. So it will say, actually, you know what? Node 2, I know already this is where this data would naturally reside. I'm going to do a read, and I'm going to do a consistency level of 1. So I will choose that node to connect to first. And the advantage of that is I don't subsequently have to do a network hop from that node to the other node onto which my data resides. So it gives you better performance. And personally, by default, token aware and DC aware is what I always do out of the box. That's just my first choice. And it's pretty nice. You also have retry policies, and these are where, well, something's gone wrong. I need to have a retry. And you've got a bunch of choices to choose from. The one in the example there, that's a downgrading consistency retry policy. And what we're doing with that one is we're saying, for example, say you wanted to have a very strong consistency of, say, all, yeah, which you would really never want to do. But maybe your use case says, I need to make sure every single replica of my data in every single data center I'm in comes back with an ACK on a write. Fair enough, you've got a use case to do that. But what happens when something goes wrong? Yeah, you need to either just handle that in your application and catch that exception and do something accordingly, or if you want, you can tell Cassandra, well, you know what, downgrade to, say, local quorum, so you're only going to your local data center instead. And you can choose that as well. There's a bunch of choices in there, and it's also fairly extensible. All of these policies, you can write your own. It's a very, very extensible way of doing stuff. We also have reconnection policies, and the reconnection policies are, obviously, this is where if, for some reason the client has lost connectivity into the cluster, what should I do? You can have a constant reconnection policy, which is every X period of milliseconds I'll try, or you've got an exponential one. I always recommend go with the exponential one, because what that means is you can be fairly aggressive with retries at the start, but you want to back off as things start to go wrong. Something's obviously up. Well, I don't want to start swamping my network or my cluster with lots and lots of reconnection policies. So I typically recommend the exponential one. Be aggressive at start, but back off if things are looking. You've also got, and this is generally my favorite thing, because this used to kill me before. You've got paging now of your data. What used to happen historically is if you were reading a large chunk of data, this would pull this data into memory on Cassandra, chuck it over to you over the wire into your application, and I was getting hit with out-of-memory exceptions, and it was painful. And the way you'd have to work around this is you'd have to do some horrible selects where you're starting to start iterating through things, chalking things up and stuff like that, and that's really, really painful to manage and look. But now you do not have to do this. Cassandra pages the data from Cassandra into your client, and it also does some really, really interesting stuff, because if you think about, imagine I'm doing a select or a read from a ton of data, yeah, and this data's paging back to me across the wire into my Cassandra, and imagine that node I'm connecting to that's giving me this data, all of a sudden it fails, and you need to. So what would you do? Well, oh God, I've got to start all over again. No, you don't. It will automatically fail over to another node, and it will resume from where it last hit. So you don't have to keep starting again, and that's very nice, because if you're doing big queries, this is a very hard thing to manage. We also have, just as I said, at the CQL native level, you also have query tracing within the client as well. And the example here is you just simply call enable tracing on your query, and from there you get back an execution info object, and off there you'll get a query trace object. And the data you kind of see in there is pretty good. I mean, you see these are the nodes. This is microseconds, by the way. So first thing to point out, it's microseconds and it's parallelized. So this is not a total time. This is each step I did. So you see how long it took to parse the statement, prepare that statement, determining my replicas, et cetera, So you can really dig into how things are going, and it's definitely your friend. So kind of coming to the end of it, here's a bunch of links, which really go to datastacks.com and you'll find everything you need there. We have all the documentation, training, all the various downloads for whether it's Cassandra, the drivers, Dev Center, Op Center, all these kind of things that will help you. So yeah, thank you very much. Any questions, if I have time? Do I have time?
Yeah, you do have time.
Good. No questions? I can talk about Cassandra 2.1 if you like. Would you like to know about Cassandra 2.1?
Yeah?
Cool. Yeah? Cool. All right. There you go. Here's one I prepared. So it's in release candidate this week. It's out the end of June. There's some very interesting features coming in there. You've got user-defined types, UDTs. This gives you the ability to create a type, and then when you create your table, you can assign that type in there. So you can get to very, very nice customizable types. So the example here, I've created this address type, and then on my users table, I have an address collection that has a map of addresses in there. Sorry? Oh, okay. I guess I won't. Do you want to put the slide back on? No? Okay, you've got user-defined types. What a user-defined type is like. All right, I think I'm off the stage. All right, guys, I'm at the booth, so come on over if you want to have a chat.
Okay, so a long time ago when Cassandra was new, I attended a talk about it, and I heard a really awesome rumor. I wanted to ask if that's still true. At that time, Cassandra couldn't be gracefully shut off. You could only crash it. And that was done so that the developers don't accidentally make it not shut gracefully when it's completely crashed. Is that still true?
No.
Thank you.
That's a great question. Anything else? Sorry? Yeah. Well, so what we're working on at the moment, I mean, there are PHP drivers out there. What we're working on at the moment is the C++ driver, and I think the plan with the C++ driver is to, once that's stable and good enough, we can start wrapping things like PHP, Node, stuff like that in there to give you a much more performant thing. And I have to confess, I'm also a little bit interested to see if I could try hooking into the C++ driver from Java as well to see how it performs. But yeah, so PHP is, we're not forgetting about PHP. It's definitely on there. And there is some community PHP drivers for native and CQL that you can use now if you like. Anything else?
There he is.
Do you have to define any indexes before you start?
Yeah, you can create you can apply secondary indexes onto your column families, or sorry, I should say tables now. You can apply them onto your tables in Cassandra. Secondary indexes, you know, you should have the same considerations around secondary indexes that you should always have. Don't go, you want to go for, you know, low cardinality. You need to be conscious of what you're doing. If you think about what you can do with a secondary index in a distributed database, it's kind of dangerous. If you were to select star from where that index and you don't have any predicates in there to indicate the partition of your data, that's going to be an expensive query. It's going to go out across your cluster. So it's there for you to use, but understand when to use them. I'd say you also have, I mean, the indexing is also going to take up storage as well, because it's also you got to store the index data. I would definitely say from a performance point of view, you're still better to go down around modeling your data around your queries. So denormalizing, query-based model, that's still the most efficient approach to do. But secondary indexes are in there when you want to use them.
Any other questions?
All right then.
Thanks
Cool.
a lot.
All right, guys. Thanks lots.